All
We
right.
haven't really changed much over the past couple of weeks, so
We've just gotten better.
yeah, slowly. Awesome. Well, Wade, it is week 27 of 2025. I think we've been recording now for this is our eighth week. Uh,
Yeah.
so short amount of time that we've been
Yep.
trying to, look good on camera. But Fourth of July tomorrow. So I gotta ask, any plans with the family or anything that you're doing out there in Oklahoma?
But yeah, I was lucky enough to be able to come down here to Norman and spend some time with my family, my wife's family. We're going to go out and pop some fireworks down at my brother-in-law's farm tomorrow. We're getting some fishing and all that stuff. So I'm really enjoying it. Yep. How about yourself?
So it's my son's birthday today.
All
And
right.
actually, we're gonna go out to Oceanside, and they celebrate the town, I guess, has their anniversary on the 3rd, so we're gonna go watch some fireworks tonight in honor of his birthday in Oceanside, and then tomorrow's the 4th, so just go to the pool, hang out, and, but anyways, yeah, so nothing too crazy. I'm excited for a long weekend.
Real quick, I want to, man. A lot of the guys, this is definitely talking to people out there in the oil field, and we're actually, we started rigging up on a well just yesterday, and so one of the things that always happens, I always feel kind of guilty on holidays, just because I usually get to spend them with family, unless we're having some big problems or issues, and so just wanted to tell all the guys out there who are working on rigs or who are out there running around the field, just thank you, appreciate it. Nothing to get done without you guys out there, and so, you know, keep on keeping on. Appreciate it.
Yeah. Oh, absolutely. I mean, it's a welcome holiday, but I know that some of us are still putting in the work, so
Yeah, it's
hey,
tough.
yeah, it is tough, but yeah, so absolutely, I'm with Wade on that. Thank you guys, and we'll keep going. Hopefully, we can provide some sort of entertainment while we're at it.
Yeah, you guys can laugh at us.
Yeah, yeah, if nothing else. So, like, some interesting news in like the California side, right? And I get all these fun political emails. And I was at the gas station yesterday. We were at like 4.53 a gallon or something like that. It's crazy. I mean, just seeing some of the comments and the people out there, they're like, or, they're still paying, high twos, low threes,
Yeah,
even in Arizona.
right.
So anyways, I mean, it's kind of bizarre. We were supposed to see a 65-cent increase per gallon, and basically I looked at it and it hadn't gone up. So I did some more research on it, and of course all the politics is going to say 65 cents. Well, 62 cents of that's already built in, so it's really a 3-cent increase, and I don't like any
Okay.
increase, don't get me
Right.
wrong, but bigger problem we have is obviously they're shutting down two refineries at the end of the year. So Phillips 66 and Valero are closing down, which they do about 20% of our production here in the state. So it's going to be really bizarre, but so that
Okay.
was one weird thing this week that we're kind of just keeping an eye on. So if there's anyone out in California that knows more about it, we would love to talk with you. Or maybe you're on the politics side, maybe you're on the refinery side. It would be really cool to chat with you guys. But the second part, and I don't know if I mentioned this, Wade, but so a few months ago, the company I work for, Falcon West, we partnered with Major League Rugby and U.S. Rugby, building up an academy program. So basically, teaching professional athletes, teaching them about oil and gas, teaching them about risk management, insurance, all of that. And one of the big parts that we've kind of figured out that we need to improve on, and I think you've gone through the PowerPoint with me, was the oil and gas part, right? So super basic. We're talking upstream, midstream, downstream. We want to put education in for each of those and just give a high level. And they're putting in 4 to 6 hours a week over 12 weeks, so it's not like they have
Right.
time to get super deep. But one really cool thing that we're working on, and I'm excited to talk with you about this off the podcast, is we're going to start building out 3-dimensional models.
Okay.
Met with an engineer. We're going to start with a horizontal well. So
Okay.
he's like, "Hey, hand draw this thing for me." And my stick figures are terrible, so like you can imagine my well drawings. But
Right.
but from kind of just like, here's a completed well, and then we're gonna. The idea is to embed this onto a website
Okay.
or some sort of web application where kids or people that are interested in oil and gas can go actually interact with this model and click on certain things and learn about it. So at a high level, like, I'm kind of excited to see
Right.
where this goes. It's going to be great for our interns, but more importantly, I think that there's an application here to keep, educating, and kids that are, 6
100%.
and up. The idea is, go learn something about it. And by the time they're old enough to either go get a degree or go pick up tools and go do that kind of thing, they already have an idea of like what they're looking at. And obviously the industry might change a lot between now and the next 20 years or 15
Oh
years.
yeah.
I'm sure it will.
Yep,
but I think that a lot of the core principles will stay the same or at least have an echo, right? So
it will. Energy reaches into every part of our life, and the more you can understand about it and know about it, the better.
can't change it, you know?
Nope.
Yeah, totally. Need to know more about it and need to educate people on it as well. So in the spirit of, I guess, educating people, I said, let's take this back to the basics this week, right? So
All right,
I guess the first thing I want to ask and talk to you about is, how does the drilling process get started on site? Like, what are the first
I
couple
got you.
things that have to happen for, for a well to actually happen?
Right. Well, there's tons of people involved in executing on a well plan, right? And so a lot of the first things that happen is you've got permitting and all those different things that happen between the company and the state. You've got to submit plans, you've got to submit tons of forms and different things in order to get approval to do that. You go out and you physically build a pad. So depending upon what the actual location looks like, sometimes they're cutting really deep into the ground to get something flat. They'll do a 15 or 20-foot cut to get a flat enough space for you to bring a rig out. Sometimes it's pretty flat already, and you're just out there, kind of tilling it up and putting layers and layers of gravel on there. After that, once the location is kind of set up, which honestly just glazed over like 2 3 weeks worth of work there.
Yeah.
Once you've gotten past that phase, you go out there and you essentially just you set your conductor and you set a mouse hole. Those are a couple of different things that the rig needs in order to be able to spud in. Once you've got a conductor and a mouse hole drilled, you come in there with the big rig at that point, and the big rig will set up. That normally takes some of the faster ones are 3 days. Smaller ones even can be down to like 2 days. But some of the bigger ones, like box on box designs, can take 6 or 7 days. And so they come in, they rig up, and then you essentially spud in. And so what you do when you spud in is the actual drilling process itself. At that point, you're kind of off to the races. You put a bit on the end of your drill pipe, motor, MWD, all those different things. You got, your drilling crew out there and all your trailers and all that stuff on location. You start drilling down below surface at that point. Up to
Mm,
that point, pretty much everything you can say it's just really associated with the surface. Nothing too significant is going on underground before the big rig shows up.
okay. So that conductor casing, it's like 20 inches in diameter, or is it bigger than that, smaller than that? It
It
varies.
usually your conductor will usually be bigger than 20 inches, but it just depends on your well plan, right? So if you're going to set 7-inch casing, maybe you'll set 9 and 5/8 inch casing. How many strings of casing do you have? Because like here in Oklahoma, one of the most common designs that I drill is a 9 and 5/8 surface. So that goes down to around 1,000 feet, sometimes 1,500 feet, sometimes 500 feet. But you'll set 9 and 5/8 down to there. Also, I'll tell you too, like that doesn't have to happen with the big rig. There could be a lot of efficiency had. So we'll have what they call sputter rigs that come out there and can drill that 1,000 feet and set that casing. So when the big rig comes out, they just drill outside of that 9 and 5/8. So, we'll set 9 and 5/8 down to about 1,000, then we'll do 7-inch down to kickoff point or through the curve, depends on what formation you're drilling. And then we'll drill a 6 1/8 inch lateral. If you're drilling if you want to drill a bigger lateral, if you want to do like 5.5 inch casing for your lateral, then you've got to drill with 8 3/4 hole. So you've got to set, 9 and 5/8 deeper if you want to do that. And so there's some places in Oklahoma even that you drill a monobore design. All right. And so you'll set 1,000 feet or 1,500 feet of 9 and 5/8, and then you just drill 8 3/4 hole all the way to TD, which is 21, 22, 23,000 feet, and none of it's cased in between there. Then you'll run like a long string of 5.5 inch casing and call it a day. So,
Mm,
there are tons. Like it's hard to answer a lot of questions because there's just so much
yeah.
variety. It just depends what the formation allows. It depends on the economics of the project. I mean, there's just so many different factors that go on there.
So thinking through this too, so, talking about the conductor casing, is that,
Right.
I mean, there's probably you're probably thinking a little bit about groundwater at that point, like, right? You want to isolate the well from the groundwater, or is that something you think about or not really?
No, that's not necessarily the case with the conductor. The conductor is even shallower than that. That surface
Okay.
casing string is the one that will usually cover up your base of treatable water, essentially. So, a lot of stuff in Oklahoma is 400, 500 feet, something along those lines, and so you will get that covered with the casing string, though.
Okay.
That's one
Cool.
of the requirements. That's part of the permitting process.
I figured as much. I just didn't know where it fit into the whole process in general. So Cool. Awesome. So another question that I kind of learned about as I was having a conversation over the week was what is underbalanced drilling?
Right.
It sounds a little riskier than normal drilling.
Well, yeah, it depends on what you call risk, right? But with underbalanced drilling, you're normally drilling with a mud weight that's lighter than whatever the formation would require, whatever the natural kind of reservoir pressure is. And so you do this for a number of different reasons. Most of the time, it's because you'd have severe mud losses if you got your mud weight all the way up there. There's a lot of fractures or things like that that are present in your formation, and so you're keeping your mud weight lighter in order to not lose all of your mud. Another one would be too, I've seen people do underbalance because you're able to drill faster. Whenever your hydrostatic is lower than that formation pressure, you can drill quicker. And so there's a number of different reasons why you do it, but really it's just whenever you're using a lighter mud weight than what you'd consider normally required.
Is there different equipment that gets used, or is it really just a mud weight difference?
Yeah, a lot of times what they'll do is, I think whenever you associate like underbalanced drilling, you could also call some of it like managed pressure drilling. And so what that's doing is what you can do is you can hold some back pressure on the well. So they've got this equipment that they'll bring out there, and you can actually dial it in either while you're tripping or while you're drilling ahead, and it essentially kind of chokes back the flow coming out of the well to hold a whatever your desired pressure is down hole at the bed. So it'll change your ECDs as you're drilling ahead. Now, the really nice ones, the really nice systems like that will just actually, they'll hold a whatever pressure you say. And so it's just constantly adjusting on the fly
That's
without you having
insane.
to intervene. It really is. There's so many cool things that go on in the oil field that, there's been so much problem solving going on, and these kinds of things that we see here like this are solutions to those challenges, to be able to allow you to drill the well.
That's really cool. You mentioned your MD, and I've heard TBD
Right,
thrown around a bit. I
right,
know it's probably a quite a simple explanation, but what's the difference between TBD and
right.
MD?
All right, so measured depth is like the actual, like, let's just say the physical distance that you've drilled, right? So if I've drilled, I'm going to give you some rough numbers. So I've drilled 10,000 feet down and 10,000 feet out. My measured depth is 20 feet, right? But whenever I only drilled, I told you just now, I just drilled 10,000 feet down. That's my
Yeah.
TVD. So
Okay.
imagine TVD as depth below the surface of the earth. Measured depth is how far your bit or the end of your hole is away from where your surface is, like where your rig is, along the path of the wellbore.
Okay. So I'd imagine that your MD is more of a volume calculation, or like
Well,
what are you using either of those for as you're moving along the drilling process?
right. So when you're drilling vertical, if you're drilling a perfectly vertical well, measure depth and TVD are equal to each other. All right. So like that's exactly the same. But as you kick off and you start drilling your horizontal, measure depth will outpace your TVD. Sometimes your TVD will get shallower. So if I'm drilling at like a 91 or 92-degree like wellbore angle as I drill out my lateral, my bit out at the end of the well will be 2, 3, 400 feet higher in TVD than where it was whenever I landed.
Really? Okay.
Yeah. Yep.
Huh.
Yep. And so really TVD the best way to think about TVD is just distance from kind of, just say surface, where the rig is physically sitting down to how far below ground, where your drilling is.
Okay. And I know there's really no, like, typical well depth, but, I
Right.
mean, what's kind of like a rule of thumb for, like, maybe an onshore, like, I've seen offshore wells that are,
Right.
30,000 feet or more. What's kind of
Right.
a typical, onshore wells depth?
So, it's changing as the industry changes, right? These longer and longer laterals, extended reach drilling is really pushing the boundaries. I think the longest well that I've drilled, measure depth wise, is like 28,600 feet, right? The deepest TVD I've ever drilled was just over 16,500 feet. I would say though, a lot of your TVDs are probably 7, 8,000 feet down to 12, 13,000 feet. That's probably a good range. I don't know across the US, but I would say that probably covers more than at least half of the wells in that kind of depth. As far as reaching out, like, man, I know they're drilling some 4 mile laterals now. When you're starting to get out drilling 4 mile laterals, you're pushing 30,000 feet measured depth, maybe even a little bit more. That's really interesting. That makes me want to go and look up like
Yeah. What's
Use
the
drilling
record?
info or whatever to see what the deepest wellbore or horizontal is here in the U.S. I mean, there's a lot that go really deep though. I mean, they've been drilling deep holes, deep verticals for a very long time. I mean, we're talking decades and decades. We've gotten away from that. Now we're going horizontal. But I mean, there's 20 and 30,000 feet deep vertical wells out there. They really punch a hole in the ground.
I'm going to put a little Easter egg if anyone's listening to this on YouTube and you go into the comments and you tell us what the
Right.
record depth is. Okay, we're going
Right.
to look it up. But if you got it right, I'm going to make sure that I send you some
All right.
local energy swag. So we'll see if
Let's
anyone
do.
catches that Easter egg.
You gotta give them measure depth or TVD. Which one are you talking about? You gonna say measure depth?
I think we got to do both. You got to do
Okay.
both.
All right. One for
Yeah.
each. All right.
Yeah.
All right.
Exactly. And I'll
On
make sure we get you
U.S.
some
land,
swag.
right? Gotta be on lower 48.
You're spot on. Yeah, I
Okay.
like the clarification. Yeah,
All
U.S.
right.
land, U.S.
Yep.
Yes, TBD and MD. I love it.
All right.
I will see if anyone picks up on that one.
I was gonna say I think the deepest stuff was drilled over in Russia. I think like the long I can't remember if it was the longest or the deep, and it was like Sakhalin Island, something like that. So, but I don't know about here in the U.S.
We can't let the Russians have the record. Like that's not okay. What I really want to see because we can't get permits done in California is I need someone in Texas to drill a lateral to Taft. All right, let's just see how that goes. That might be a little far. Anyways.
When you think about it, it's really interesting. I mean, think about 4 or 5 miles from where you're at right now. I was in a meeting one night. We were talking a lot of operations stuff, and there were some guys who weren't, like fully hooked up on operations. It's not what they do every day. And one of the guys who was there was talking about a lateral they had just finished, and he was like, "From where you're having dinner right now, it's the airport that you flew in at." You know what I mean? And we were downtown Oklahoma City, and the airport is over there, essentially on southwest side of Oklahoma City. And it's just it's crazy to think about what how far 4 miles really is to be able to reach out with a motor and drill bit.
That's pretty wild. Like, yeah, I mean, I just think about, I mean, if I put 5 miles in perspective or 4 miles in perspective for myself, like from my house, that gets me out of town, but I got to go over a
Right.
major hill to get there. So it's
Yep.
like, that's far. Yeah.
Yep.
So kind of going back to the geologist that I met with, right? He's doing these 3D models with Blender. He's getting all this topographical and subsurface data, through various sources, and they're
Right.
real. I'm excited to show you
Right.
what he's doing, but I'd imagine that when you're determining the depth of a well, that you're probably
Uh-huh.
getting a ton of data to determine, okay, this is what we expect the results to
Right.
be, right? Because I mean, at the end of the day, you're putting a project together that's going to cost millions of dollars. You're going to have
Right.
a lot of information coming in, right?
Oh, 100%. If you're gonna invest seven to some of these wells are 20, $25 million. If you're gonna invest that much money, you better know what you're doing. So, like you're saying, he's going out getting a lot of information. There's tons of different information sources you can go to. Offset wells in the area are definitely one that you would start with. If you're looking at old verticals or horizontals, there, you'll look at mud logs, you'll look at gamma ray logs, you'll call tops on those, different formations that you're going to be targeting. They can also do seismic. So a seismic's a really good source for information because if you don't have really great well density, I mean, we talked about it the other week down in the Permian. I mean, there are wells everywhere. The ones I've drilled down there, I mean, you can almost like set it and forget it. Like you're drilling so close to all of these offset verticals that you've got really, really high confidence in where exactly you should be. Here in Oklahoma, some sections, if you're drilling a little bit deeper, like our Miss and Woodford wells out in western Oklahoma, you may only have one penetration point in that entire mile, and your closest one's 2 or 3 miles away. And so
Man.
being able to interpolate with accuracy between those two data points is really, really difficult. And there's just a lot of uncertainty that exists between there. It's not as easy as just drawing a straight line between them and saying, oh, that's what it is. So you sit outside, look at the surface of what's going on around you, and that's exactly what's going on downhole, if not even more so.
I mean, I kind of think back, like I read about guys that were drilling for water wells, right? And they had these sticks, like these, they'd walk around with
Like
these
witching
sticks, like,
sticks or
yeah,
whatever.
the
Yeah,
witching
yeah.
sticks, exactly. You know what I'm
Uh-huh.
talking
Uh-huh.
about, right? And I'm like,
Oh
I
yeah,
wonder
I've
if they do
I've
the
heard
same
of it.
thing for oil and gas back in the day. I'm sure they
I
did.
think you read some of those books, The Big Rich or whatever, and
Yeah,
yeah, there
yeah,
were there were there were some guys who swore by them. They missed a lot, so I don't know how I'd say that they were very good to use, but
yeah.
I guess they convinced some people.
It's like my dad said, better lucky than good, right?
At times, at times.
Yeah. I think the thing that I'm most excited to talk about or ask you about today is mud pulse telemetry. So, what is mud pulse telemetry? I think you know a little bit about it. Would love to just get a high level and maybe any fun details that you think of.
Yeah. So, well, mud pulse telemetry is one of those things like it's really basic and it's been around for a really long time. But like whenever I first got on a rig, it was one of like the things that just hit me. I was like, they do some really cool things here. I mean, it was just one of those like, so essentially what mud pulse telemetry is there's you're pumping mud down hole, it goes down through your drill string, it goes down through your motor, goes out your bit, and then it comes back up the annulus, right? When it's coming up the annulus, it's bringing all your cuttings, it's bringing all the samples, all that different stuff, right? It's cleaning the hole. But inside of your drill string, when you're using mud pulse telemetry, you've usually got what we call an MWD. So that stands for measurement while drilling. The guys who work in the field know that it really stands for movie watching dude. But as the fluid's being pumped down through there, there's a poppet in there. And that poppet is controlled by essentially by a board down there. And it's taking in all the information that's going on around it, right? So it'll be taking in gamma ray, temperature, shock and vibe. So how much the tool is moving. Not only just in the XY direction, which is laterally, but also in the Z direction going up. Sometimes it'll measure like what's going on downhole with the drill string, right? So it doesn't matter that your rotary up on surface is spinning to the right. In really bad conditions, you can get stuff called like backwards whirl, to where the torque is so big that the drill string catches and then it releases backwards for a second. So all that information that it's gathering downhole, the mud is coming down through that poppet, and that poppet is just opening and closing in just a very, very rapid succession. And whenever it opens and closes, it creates a pressure wave. That pressure wave travels up through the column of mud, and on surface we've got transducers that are on there, and that transducer is reading those changes in those pressure waves and interpreting that into the usable data, whether that's gamma ray or pressure or temperature or whatever. And so your downhole tool and your surface equipment are both speaking the same language in terms of where those little pressure waves should be hitting, and it's communicating and telling you real time. I mean, within a couple of seconds of what's actually going on downhole. It's really just an absolutely amazing technology, really cool. Best way to think of it is probably Morse code, but Morse code through pressure waves. The other thing you got to think about too is like, think about what's going on. Like you've got these pumps that are pumping that mud. You've got just all of these different noises and things that are vibrations, the movement of the drill string, all that stuff that can create interference, and it's still able to decode down to like, I mean, when I talk about a pressure wave, like good ones on surface, you're talking like hundreds of pounds. But when you're getting out at 25,000 feet, I mean, you're decoding 15 psi pressure differences in order to be able to get that real time data. It is. It just blows my mind.
I'm sure it's constantly evolving, but are there other ways to get the same data, or is that like we just all use MWD?
Yeah, MWD. Well, MWD stands for essentially like the tool downhole. There are different ways of getting the information up
Sorry,
the
the mud
surface.
pulse telemetry. I'm sorry,
Yeah,
I'm
yeah,
all mixed up.
no, yeah, yeah. So as far as mud pulse telemetry, I would say it's the lion's share of data transmission. There's other different ways. The two that come to mind for me right now, one is wired pipe. So essentially, like your drill pipe has the ability to communicate from joint to joint. There's like these little, I don't even know I've never used it, right? But it's super expensive. I know they use it in some offshore stuff too. But essentially, like when you make up your drill pipe, you're making up a data connection that goes all the way down to the tool. And so all that information is set up. You can imagine with mud pulse telemetry, you're limited on the amount of information you can send up because you're sending up these pressure waves as you're going. The wired pipe can send it up with essentially no delays. I mean, it's like broadband versus a K dial-up connection.
So you're kind of thinking like with what you're talking about there, it's similar to like a wire line, but during the drilling process, effectively. Then,
Right. Yeah. But it's actually built into the wall of the drill pipe.
okay,
Yep. Yep.
that's
And
got to be
so,
expensive, man.
yeah, it's not cheap. I don't know exactly whenever it was started. It's been around. I know for at least a decade. That's when I started hearing about it. I think they've used it offshore probably even more than that. But yeah, it's I would say it's kind of a niche deal because one, like you said, it's super expensive. Two, if you have any kind of problems making up your drill pipe, like you've now broken your connection, and you're not going to be able to get your data up. And three, like you just usually don't need that dense of data. The other one, though, is a really cool one. It's oh my gosh, I just blanked on it. I always it's like black box technology. It's
Yeah,
EM, oh, it's EM. So it's man, like EM sends up actually through just like through waves. Like it doesn't even go through the mud or anything like that. It's a challenge though. It doesn't work in a lot of things because like anhydrite formations, certain formations will actually block that transmission to surface. You can put little repeaters in your drill string that will, essentially the tool is talking to a repeater that's say 10,000 feet up in your drill string, and then that'll try
hmm
and repeat it to surface. But
got it.
it's it's
And
unreliable, I think
you're
is what I would
meaning
say.
electromagnetic, right? Is that
Yes, yes.
okay?
Oh
All right.
yeah, sorry. Yeah, yeah. It's electromagnetic. Yep,
Okay,
yep.
cool. Just want to be clear in case someone out there was curious what that stood for.
Yeah.
If
Oh,
they've
sorry.
even made it this far.
Yeah, I jumped right past it.
You're good, you're good. No, it made sense. So we're kind of getting towards man, there's so much I had like so many things this week that I was like, I want to talk about. But I'm familiar with mud logging
Okay.
only from, the fact that we have clients that do mud logging, we have clients that do geosteering. Insurance carriers always think that mud logging is a high risk activity. And the reality is it's not, right?
Right.
It's very much, I think it's an analysis based position, right?
Right. It is
But
on
anyways,
location.
yeah, it is on location, but they're not standing over the hole, right? And a lot of these guys,
Yeah. Not
they're
all the
taking the
time.
samples back to their house, or they're
Right.
getting them brought in, and they're working from
Working
from
in
a
a
trailer
trailer.
kind of thing, right?
Right. Yep.
It's just part of it. And then so anyways, my friend posted a photo of a handwritten mud log, and I think it's an older well
Oh,
that
okay.
he's looking at, but and I think I showed you the photo, but on the
Right.
right hand side of this picture is sort of a description of the
Right.
mud, right? And then
Yep.
on the left we've got some sort of there's a line, right? And we're probably looking
Right.
at some sort of gamma ray. Is that right?
Yeah, looking at that, it's kind of hard to see over there, but it definitely looked like it was a gamma ray. A lot of times on mud logs, you'll see something like like your gas readings as well. But just looking at the log itself, I kind of felt like it was probably a gamma ray. But yeah, like you're talking about over there on the right too. Essentially, what they're doing over there on the right is just they go back there to the shakers. They've usually got a basket or something along those lines. They'll catch some samples coming off. They'll clean those samples off with water or with diesel, depending on if you're oil based or water based mud. And then they take those back over there to the trailer and then they analyze them. They're either putting chemical reagents on them, they're looking at them underneath microscopes, and they're just describing them. Everything from the color of them to if you're in water-based mud, sometimes you can see oil stains. So they'll say, hey, we see some oil stain on these samples, and so you're really just giving a physical description of the formation that you're drilling, the samples that are coming up and over the shakers.
Okay. So yeah, they are actually collecting samples. Is there any scenario where a guy that's doing the mud logging would be completely off site? I mean, when they tell me, "Hey, we're working from home," right? Is that even a possibility really,
Right.
or how would that work?
That'd be a lot more challenging. I'm trying to think about that. I mean, they do have some like remote gas detection software and all that, so it just kind of sits there right in the like at the possum belly of the shakers, and so it's doing that remotely. Most of the time, mud logging though, I mean, you're really looking at samples, and so you've got to physically
Yeah.
get in touch with them in order to be able to
Yeah.
tell exactly what's going on there. So
Yeah.
yeah, and unless they and I really haven't I don't know that I've heard of something that's really automated, in terms of somebody being able to catch a sample, throw it in a collection something, and then it automatically analyzing it. So
Well,
yeah.
and even if you Amazon overnight that package, you still need the data like right then, right? I mean,
Right.
it's more valuable in the moment, right?
It depends. I mean, sometimes what'll happen. So let's take like a lateral or something like that, for example. We will catch samples every 500 or 1,000 feet, something along those lines. And what they do is they send those off for an analysis, like X-ray diffraction or something along those lines, that will give the completions team information that they need in order to be able to frack the well a little bit more efficient or whatever questions they've got. There are definitely some samples analysis that happen offsite and even post well. But whenever I think of mud logging, I think of kind of what you're saying, like real time on the rig, kind of part of that crew out there. Yep.
So maybe I'll ask this because I was listening to another podcast and they were
Uh-huh.
talking about produced water. So
Okay.
this would be the water that, as you're drilling down, you're obviously bringing stuff up and water is one of those things, right?
Right.
I mean, what do they do with the water?
Oh, okay. Well, I think whenever you be talking about produced water, you're probably talking about like your flowback phase, right? So like
Okay.
we've drilled the well, we've completed it, and now you're starting to get you'll get some sand back, you'll get the water that you fracked with back, you'll get produced water, which was just you know already in the formation, and then hopefully you're getting hydrocarbons too, your oil, gas, NGLs, all those different things. And so a lot of wells, you get a lot more water than you really want, and a lot more water than you really want is a relative term. I've drilled wells that flow back like 5,000 barrels a day, and it is really, really expensive and almost uneconomic. You can get a really good amount of, what I would say, I'm going to do quote unquote, good amount of oil and gas, but to dispose of the water costs so much that it makes the well uneconomic and you just don't drill
Hmm.
anymore.
Okay.
That's where you see. So as far as getting rid of the water, a lot of people will go re-inject it, right? And so that's where you hear about injection wells. You transfer it and then you go and you inject it down hole in another well in a formation that has a lot of porosity, permeability, all that stuff. And so you just inject it back down into the earth. Now, some places, if you're drilling tons and tons of wells, I drilled some wells with my last company, company before last, out in the Texas Panhandle, and we recycled our produced water. So we would take it. They had these huge surface, essentially frac ponds is what you call them.
Yeah.
We'd put that produced water in there. You'd treat it with like biocides and things like that to make sure that it's not growing bacteria and all that. And then you'd have that on surface. You'd aerate it a lot so that the air keeps all that anaerobic bacteria from growing and all that stuff. And then whenever you're ready to do another frac, you transfer it. You either pump it out or you transfer it over there to your frac site and then perform more fracs with it. And so you're essentially recycling that water. When you've got a really big program, it's one of those things that I think can be economic. It's extremely costly. It's very difficult to do, to transfer that water, to treat it, to store it, and then to transfer it back. But it's done. So there's a couple of different things you can do with that produced water.
And I would imagine that it takes, I mean, a lot of surface area of the land in order to, because those frac ponds can't
Yeah.
be, super, super deep, right? It's not, they're more shallow than they are deep.
Right.
So,
Yeah, yeah, they're
yeah.
10, 15. I don't know if we ever, I'm sure some are out there are 20 feet deep. And we did some of this too out in Louisiana a little bit. I don't know that it was really recycling over there. It was really filling frac ponds, but yes, I mean, you got to do it in a place that's not got tons and tons of people around. This isn't done in the Dallas Fort Worth area.
Yeah. I'd be curious if there's a way to make that water at any point drinkable, or usable again by people, right? So
Right.
it's probably like salt water where it's like, how do you turn salt water? It's expensive. It's almost,
Right.
you can't do it. It doesn't make
Right.
sense.
Yeah, it is. It's like you're saying, there's a lot of stuff in there. I mean, there's also, when you're doing a frac, you're also putting some chemicals in there as well, either to kill bacteria or to enable the frac to work better, like friction reducers and things like that. So, removing all that, I think, would be really, really difficult. Let me say this. If somebody could have done it and made money, they probably would be by now. That's not to say the technology
Yeah.
won't change, but
Yeah.
if somebody came up with that, they'd be retired right now.
It makes sense. Yeah, I totally gotcha. Well, the last question for today, we're hitting 40 minutes and probably,
Oh, okay.
we'll edit this down
I
a
mean, it
little
goes
bit, I
by
guess.
fast.
It does, doesn't it?
Yeah.
It's fun. I'm like
I enjoy
enjoying
it.
these more and more. But the last thing, and I don't know if you know the answer to this or not, but
Okay.
what is a contract pumper?
Okay. Yeah. So a contract pumper is just a normal pumper, right? So a pumper is a guy who goes out and drives a route pretty much every single day. So he's got a list of wells that he's responsible for, and he goes out there and checks and makes sure that everything's going well. So a lot of times he'll gauge tanks, how much water, how much oil. If you're flowing gas off of it, you're making sure that all the valving and all that stuff's right. You're making sure that there's no leaks. You're fixing anything. Like these are guys who are out there like turning wrenches, and making sure that everything's going well. And so contract pumpers no different than the company pumper, other than the fact they're 1099. So
Okay.
yeah, these are the
Yeah,
guys that
interesting.
put a lot of miles on a truck and leave those those F-250s running all day long.
Yeah. I'm sure, like, I don't know, that'd be an interesting I don't know if you could do that as like a job to get started. Like if you're mechanically inclined, I mean,
Right,
I don't know the knowledge level. I'm sure it's got to be pretty
right.
good, but once you've worked on a couple of them, I'm sure you start to see a pattern, and I'm sure a company would train someone to work on that stuff too. But
Yeah, it's kind of like any job. I mean, when you first start it, oftentimes you're not qualified at all. You know what I mean? But
yeah,
you
yeah,
ride around, you start seeing problems, you start getting experience, and before you know it, you're kind of independent and able to do it on your own. So, yeah.
hmm, okay. If I had to do that, I'd probably I'd work for a company first, and then I'd try to go independent after that, probably. But that's
I
just who
got
I
you.
am,
Well,
you know?
everybody's different. There's some
Yeah.
guys who just want to stay contract all the time. Other guys, the benefits of working for a company is health insurance and
There's a
some of
lot of
those
them.
things. Yep,
Yeah.
exactly. So,
There's a lot of them.
yep,
Cool. Well, this has been super fun
yeah, I've really
catching
enjoyed
up
it.
with you. And like, I don't know if you guys can believe it, but I still haven't met Wade in person,
That's right.
which
Well,
is
you said you're going to make a trip. We'll find
October.
you.
I'm
We'll
gonna
find
wait
you a
for your
rig to
heat
crawl
wave to
around.
break, man. Once your heat goes down, we'll talk.
Oh, today's beautiful.
I
Man,
know. I'm sure
yesterday
it is.
it's struggling to hit the 90s here in Oklahoma right now, which is crazy for July.
Yeah. We're gonna try. So last week when we talked to Scott, I spun up a little newsletter again. You remember we tried Substack early, and I was
Yeah.
like,
Yep.
we don't really know what we're doing yet, so why are we writing a newsletter? And maybe it still is the case, but I'm gonna send a newsletter out with some topics that we talked about during this convo. So,
Awesome.
and there's a couple stories that I got, just like weird little clips, from just fun stories about coolers and site reports that were fun. So just little pieces in there. So hopefully, if you want to go check it out, I'll put the
All right.
link in somewhere. I think you'll get the email. Wait, I signed you up,
Okay.
so enjoy the spam.
Perfect.
But everyone else can check it out. Our new
I'll
website
check it
is
out.
Local Energy. Oh, I could get .com. It was $15,000, so it's localenergy.io.
All right. Maybe one day.
All right, guys. Well, hey, have a great 4th of July. Thanks for joining Wade and I. If you have any questions, leave them in the comments, and we'll catch you next week.
Thanks, guys.